We're going to talk now about bone development and growth. This is called osteogenesis. So if you see the word osteo, that means bone, and genesis means to make new. So osteogenesis is the process of making new bone. Another word for it is ossification. So again, it's the process of forming bone. So this is occurring when you have an embryo that's inside a mother's uterus. So for example, here we have an embryo at 4 weeks, which doesn't have a skeleton yet, no bone. But what it does have is connective tissue, and the skeleton is going to develop from this connective tissue. At 16 weeks, you'll start to see the formation of some new bone. And then, of course, as the embryo grows in the female's uterus, you ultimately get to the full skeleton, which will continue to grow to the adult form, which is what we've got here. So there's actually two types of ossification, or two types in which you can grow new bone. The first is called intramembranous ossification. These two types of ossification differ from what type of bone you're going to form. So for intramembranous ossification, you're going to form skull bones and the clavicle. The clavicle is your collarbone. And importantly, you're going to do this without using cartilage. So let me explain what these bones come from. They first start from a mesenchyme tissue, the mesenchyme membrane. So remember, all connective tissue comes from mesenchyme origin. It's like the ancestor. So here's an image of new bone forming. So in the blue here in the background, you have the mesenchyme membrane, and in the middle, you have new bone starting to form. How it forms is at the ossification center. So this area right here that you're seeing is the ossification center. And importantly, what's in the ossification center is the osteoblast. Remember, the blasts are the immature cells. And these osteoblasts' job is to create new bone. So they're going to start to put down new bone. So over time, you'll notice that these are still the osteoblasts. And then you see right here, the new matrix of the bone forming. So again, this is the case for bones that are going to be your skull bones and also your clavicle. Our second type of ossification is called endochondral ossification. Now this is going to form all the other bones of your body. And this bone is not going to form from that mesenchyme membrane. Instead, it's going to form from another connective tissue, the hyaline cartilage. So remember, hyaline cartilage is really strong and really tough. So here's what's happening. Here you have some hyaline cartilage. So that's, again, the foundation for these bones. Then, like before, you have the ossification center with the osteoblasts. So again, these osteoblasts, they're going to lay down new bone. So right here, you have the start of an ossification center. So here you have the ossification center, and you have the new bone forming. So more bone is forming, ultimately until the entire length of the bone is formed. So remember, this is endochondral ossification, and it's used to make all the other bones in your body except for those skull bones and the clavicle. And the start is hyaline cartilage. All right, so next we're going to talk about this concept called the epiphyseal plate. The epiphyseal plate is important because it allows for rapid bone growth. So for instance, in children that are growing really quickly, they're growing taller because their bones are growing longer. So right here, you can see the epiphyseal plate in the cartoon version. And here's another epiphyseal plate. It's in this image, this is actually your femur bone, your thigh bone. And then this is actually your tibia, which is your shin bone. So your kneecap would be right here. If you look really closely, you can actually see this line going right across there and down here. That is your epiphyseal plate. So you'll find it between the epiphysis and the diaphysis. So remember, the epiphysis is the bone end, and the diaphysis is the shaft in the middle. So again, this is actually cartilage. And what it's going to do, again, is give rise to new bone. So you're going to get new bone growing from the epiphyseal plate. So here you can actually see in a child, even on the finger bone, right there, there's the epiphyseal plate, right there, and so on, where all these little arrows are. Notice in the adult, you don't have the same epiphyseal plate that you're going to see in the child. Instead, what you have are the remains of the epiphyseal plate called the epiphyseal line. And that's because, again, the adult bone is not going through rapid growth. So this is actually interesting because if you actually find a skeleton and you don't know if the person died as a child or an adult, let's say you find someone that's 3 feet tall. This is important in like archaeology. You find someone that's 3 feet tall and you want to be, okay, say did this person die as a child and that's why they're only 3 feet tall, or did they die as an adult and they're just short? So again, what would you look for is actually the presence of an epiphyseal plate. If you find the epiphyseal plate, you know it's a child, but if you only find this little epiphyseal line, then you know it's an adult. All right, so now we can talk about bone remodeling. So bone remodeling is the idea that you can actually keep bone active, and active bone has to have a balance. It's important that you can balance bone resorption with bone deposit. So what bone resorption is when you actually break apart bone, or the osteoclast, which remember are the cells that actually destroy bone. So bone resorption is you're reabsorbing the bone, you're breaking it down. Bone deposit is when you make new bone. So that would be the job of the osteoblast, which remember lay down new bone matrix. So for example, if you had some injury and you need to put down some new bone for strength, you would go through bone deposit. So it's important that you balance out the two of these. So here are some pictures of osteoclast and osteoblast at work. So in this particular picture, you have bone resorption. So the osteoclasts are working faster. And then here you have bone deposit. So in this case, the osteoblasts are working faster and putting down new bone. But it's important, again, to have the balance between the two. If you have too much bone resorption, you're going to lose bone. Or if you have too much bone deposit, then your bone's going to get larger. So again, this becomes important when you need to talk about repairing bones. So a fracture is when there's a break in the bone, and the break you can repair through this process called reduction. Reduction occurs when the bones are realigned. So you have the bone end realigned. So here you can actually see some fractures here, right here, and so on. And to help you do reduction, a lot of times what you're going to need is, for instance, a cast. The cast will help realign the bone. But you can also do things like a plate or a pin or a rod. So these artificial metal structures will actually realign the bone. So that way when they grow back, they'll grow in the correct position. Now this is the process down here of the bone naturally repairing itself. So again, bone will naturally repair itself. You don't have to do anything. The important thing is to line it up so it grows back in the right place. So you'll see here that blood vessels are coming. You'll get some cartilage, which is going to give rise to new bone. And then ultimately the bone's going to heal itself. Let's lastly talk about some disorders of the bone, specifically osteoporosis. So if you take a look at this word, you see osteo, which you should be thinking bone, and then porosis. You might see the word pore in there. So what osteoporosis is when your bone is porous, meaning it has a lot of holes in it. And so the bone is going to have low mass or low weight because, again, it has a lot of holes. So take a look at these two pictures. The one on the top here is normal bone. This is spongy bone with the trabeculae. And then here are the pores. And then look down here at osteoporotic bone. So hopefully you can notice the difference that in these trabeculae, you'll see these little tiny holes or little tiny pores. So this bone is going to be a lot weaker. So just to summarize the second part of the bone lecture, we know that ossification occurs in the embryo from connective tissue to form bone by two ways, either intramembranous or endochondral ossification. And finally, bone needs to be remodeled and repaired throughout life to stay healthy.